Hi, this is Walter Stone, and this is Unit 9, Lesson 1 on quadratic equations. And after finishing this lesson, you should be able to solve quadratic equations by using the square root property and solve quadratic equations by completing the square. So a quadratic equation is of the form ax squared plus bx plus c. And back in Unit 6, we had equations like this, and you used factoring to solve these equations. And that's a good strategy to use. But in Unit 9, we're going to be working with some new strategies that you can use if it's not easy to factor the polynomial on the left-hand side. So if we have something of the form ax squared plus bx plus c equal to 0, where a is not equal to 0, because we want to be able to have that ax squared term, we have a quadratic equation. So our first objective is that we want to be able to solve quadratic equations by using the square root property. So that property says that if we have an equation of the form x squared equal to a, then x is going to be equal to plus or minus the square root of a. And the reason for that is if I square the square root of a, then we get a back. And if I square the opposite of the square root of a, we'll have negative square root of a times negative square root of a, which is positive a. So we would, in order to get all the possible solutions, we have to take the positive and the negative square root. So for example, if we want to solve x squared minus 81 equal to 0, what we can do is make sure it's of the form x squared equals a. So we can add 81 to both sides, and then we can use the square root property to say that x will either be positive or negative 9. And that is because if I take positive 9 squared, that'll give me 81, and 81 minus 81 is 0. And the quantity negative 9 squared is 81, so 81 minus 81 is also 0. So we have the two solutions. So pause the video and try solving this equation, and then come back and check your solution with my solution. So here, you probably did the exact same thing as you did with this equation. You can add 25 to both sides, and then if x squared is equal to 25, x would have to be plus or minus 5. And 5 squared is 25. 25 minus 25 is 0. And negative 5 quantity squared is 25. And 25 minus 25 is 0. So sometimes we'll have equations that are a little bit more complicated. So here, our goal is to get x squared equal to a. So if we start off with 2x squared minus 7 equal to 91. We can add 7 to both sides to get 2x squared equal to 98. We can take half of both sides to get x squared equal to 49. So x will be plus or minus 7 in that case. So try this equation, 3x squared plus 2 equal to 77. Pause the video and then come back when you want to check your solution. So if you thought out the way I did, you probably subtracted 2 from both sides and then divided both sides by 3. And when we use the square root property, we get x equal to plus or minus 5. So here, in the third example here, we have that a big question here is 5x squared equal to negative 80, does that have any real solutions? Well, if you have a number being squared, the square of a number is always going to be positive if x is a real number. And a positive number times a positive number like 5 is also going to remain positive. So we have a positive number on the left and a negative number on the right. So that causes kind of a contradictory situation. So what we say here is that no, there are no real solutions for this type of equation. So you want to be on the lookout for that. And in Pre-Calc 1, or you may have learned this in the past, there's a set of numbers called complex numbers or imaginary numbers that help us come up with solutions that we can write down for this equation. But right now we're just going to stop at this idea right now that we have no real solutions. If we have x squared equal to 40, then we can take the square root of both sides, and we just have to make sure that we simplify the square root on the right-hand side. So if x is equal to plus or minus the square root of 40, 40 is 4 times 10, and the square root of 4 is 2. So we have plus or minus 2 root 10 in that case. Pause the video, try this one. There's the solutions here, ignore it for now. See if your solution matches up with my solution. So here with x squared equal to 18, we would take the square root of both sides, and we just want to make sure that we simplify the square root of 18. And the largest perfect square that is a factor of 18 is 9. So we can write 18 as 9 times 2. And by this, the product property of square roots, we can write that as the square root of 9 times the square root of 2. And the square root of 9 is 3. So if we have x equal to plus or minus 3 root 2, those are the solutions to that equation. So in example 5, we have the square of a binomial equal to a number. And this is a case where we can use the square root property. We can take the square root of both sides. So we would take plus or minus root 7 on the right-hand side, and we can add 4 to both sides to get 3x equal to 4 plus or minus root 7, and then divide both sides by 3. So we get 4 plus or minus root 7 over 3. So we really have two solutions here, the positive version and the negative version. So if we have 4 plus root 7 over 3, that's one of our solutions. 4 minus root 7 over 3 is another one of our solutions. So try this problem where we have 2x plus 3 squared equals 7. Pause the video, come back, and check the solution. So here with this equation, you probably used the prior example. Taking the square root of both sides, we have 2x plus 3 equal plus or minus root 7. We can subtract 3 from both sides, so we have 2x equal to negative 3 plus or minus root 7. And then we can divide both sides by 2, and we have negative 3 plus or minus root 7 over 2. And here we have the two solutions to that original equation. So this is helping us with a new technique called completing the square. And to complete the square with an expression like x squared plus bx, we take half of b and square it, and we then add that to this expression, and that would complete the square. So we take half of b and square it. Adding that number completes the square. That is, we obtain a trinomial that's the square of a binomial. So for example, to complete the square of x squared plus 6x, we add the square of half of 6 to obtain x squared plus 6x plus 9. So half of 6 is 3, 3 squared is 9, and that completes a square. That makes, we can write x squared plus 6x plus 9 as the quantity x plus 3 squared. And we can use that idea to solve the following equations. So in example 6, I wrote the original equation. To set up completing the square, I subtract the constant term from both sides. And then if I look at b, which is 10, and x squared plus bx, half of 10 is 5, 5 squared is 25. So if I add 25 to the left-hand side, I have to make sure I add it to the right-hand side. So the right-hand side becomes 24. So on the left-hand side we can write as x plus 5 squared. So like the equations we did on the prior page, we now have the square of a binomial equal to a constant. So we can use the square root property and say that x plus 5 is equal to plus or minus 2 root 6. So the 24 is 4 times 6, and the square root of 4 is 2. So that's why we have plus or minus 2 root 6. We can subtract 5 from both sides and get x equal to negative 5 plus or minus 2 root 6. So try this technique with the equation x squared plus 8x plus 3 equal to 0. Pause the video and then come back and check your work. So here I subtracted 3 from both sides. And then b is 8 now. So 8 over 2 is 4. 4 squared is 16. So I had to add 16 to both sides to complete the square. And so I have x plus 4 squared equal to 13. So when we take the square root of both sides, x plus 4 is plus or minus root 13. We subtracted 4 from both sides to get negative 4 plus or minus root 13 on the right-hand side. So we were able to solve this equation for x. Now, a big idea here is that in order to complete the square, the leading coefficient has to be 1. So here, with 9x squared minus 6x minus 4, the leading coefficient is not 1. So I divided every term by 9 and simplified. So this equation simplifies to x squared. 6/9 is the same as 2/3. So I have minus 2/3 minus 4/9 equal to 0/9, which is 0. And then we can add 4/9 to both sides to set up completing the square. Now half of 2/3 is 1/3, and 1/3 squared is 1/9. So that's why I'm adding 1/9 to both sides. So we'll have x minus 1/3 squared equal to 5/9. So by the square root property, x minus 1/3 will be plus or minus root 5 over 3. And we can add 1/3 to both sides to get 1/3 plus or minus root 5 over 3, which simplifies to 1 plus or minus root 5 over 3. So in the next equation, try that technique to solve this equation by completing the square. Pause the video, try it out, and then come back and view the solution. So here I made sure to divide every term by 2 to get a leading coefficient of 1. I added negative 1/2 to both sides. And then half of 2 is 1, and 1 squared is 1. So adding 1 to both sides completes the square on the left-hand side. So x plus 1 quantity squared will equal 1/2. And then we can take the square root of both sides using the square root property. Now the square root of 1/2 is like 1 over root 2, and I rationalize the denominator to get root 2 over 2. So x plus 1 is equal to plus or minus root 2 over 2. And we can subtract 1 from both sides. And then we can think of negative 1 as negative 2 over 2. So negative 2 over 2 plus or minus root 2 over 2 is negative 2 plus or minus root 2 over 2. Okay, so study these examples, do the online work for this section, and we will see you in class.